We're going to have a look at a pulse width modulation LED brightness controller. This little guy right here, which costs a couple of bucks on eBay, and it says it operates on anywhere between 12 and 24 volts, puts out 8 amps, and we're going to power it up and see what things look like. I have it connected to just a string of LEDs here, a little strip of light emitting diodes, and I've got an oscilloscope display set up so that we can see what the voltage applied to those LEDs looks like. So I'm going to now turn the control up a little bit here. I can just start turning a potentiometer up and down like that. If I turn off my overhead lamp so that it's quite dark, we can then see that the light emitting diodes will give me more and less brightness as I turn the dial on this guy here. The oscilloscope shows me what's happening in this case. As I rotate the knob to change the output voltage, the voltage, which is 0 applied to the system along here, is for a greater period of time than the voltage here, which is about 12 volts right along there. And as I rotate the knob, then the 12 volt portion gets larger, the 0 volts gets less. So here I'm applying more and more voltages until finally constant 12 volts, and reducing the pulse's length, so that until eventually they're very, very tiny and the intensity of the display has dropped a lot, until bingo, it's gone. So there's pulse width modulation leading to greater or less brightness. So here you can see the LEDs themselves. Maybe if I put them out here like that, extremely bright, flooding the whole system and getting dimmer. Very bright and dimmer until gone. Okay. That's working nicely on this 48-inch strip of LEDs, which takes about 1 amp. So we're operating at only about 1/8 of capacity, and that's as far as I've tested it at this point.